Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore a new way of fine-tuning language models or fine-tuning AI models called REFT, R-E-F-T, which is a new member in the family of PEFT, parameter efficient fine-tuning. You would have earlier heard of LoRa, QLoRa, DORA, and so on and so forth. There are 50 others. And now we have REFT, representation efficient fine-tuning, and that's what we are going to look into this video. We're going to also look at what kind of task specific instructions we can put that in model weights, can ask the model to learn new kind of skills, very domain specific or really downstream, and we'll see how we can create a dummy data using ChatGPT as well. And you can take that data, fine tune using REFT on some of the language models or the large language models like Tiny Llama, Llama 3, uh, Mistral 0.3 or whatever. Okay, that's the plan. And I'm also going to give you a bit of theoretical aspect behind REFT. We're going to see how it is different from LoRa, DORA, and thousands others that would have seen earlier. Let's jump into REFT, guys. Now, if you look at here on uh, GitHub repository of REFT, representations fine tuning. So representation fine tuning for language models by Stanford NLP. And you can see it's by Stanford NLP. Stanford has given a lot of Stanford NLP, by the way, to be more specific. They have given a lot of libraries, frameworks, methodologies for the AI community, for the open source community, and that's what it is. Now, if you go to Stanford NLP here, okay, I can find out n number of repositories. They have core NLP, they have Glove. Glove was again created by them. Stranja, you can see different libraries that people uses, and the credit goes to Stanford NLP team for creating all of these libraries that we work with. Now let's go back here on pyreft, and you can see representation fine tuning, blah blah blah. One to fine tune, uses a fraction of parameter count. So fine tuning large language models are really pain in the neck because it might take a lot of compute and you have to burn a lot of money. Even we have LoRa, QLoRa and stuff. You want to fine tune for multiple epochs, you have to burn multi you have to burn a lot of money on multi GPUs. Okay, and that's why these kind of techniques can be really helpful if you want to put some really specific task-based instructions. Now, you can find out they have given some Gradio app to run it, a 30-second live demo on emoji chatbot. I'm also going to do something with emojis today. I have created a very interesting data sets and I'm going to show you that in a bit. But first, let's go into REFT, guys. What do we mean by REFT? Okay, what is REFT and how is it different from the traditional methods that we have? Now, if you look at the traditional PEFT methods kind of update a small number of model weights, to adapt large neural models to new tasks, right? It's a very difficult task to do that. Okay, now in REFT method, in contrast to updating a small number of model weights, it basically operate on a frozen based model or a frozen language models and learn task specific interventions on hidden representation. That's what it's a bit different. Now, particularly if you look at REFT can again be categorized into different categories. It has something called low REFT, which is again low rank, and again low rank linear subspace, right? Similarly, we have low rank adaptations for LoRa, if you are aware with LoRa, and similarly here we have low rank linear subspace REFT. We're going to talk about that. That is even more parameter efficient. See, here we all talking about to make it more parameter efficient. So if you make this process more parameter efficient, it will be really taking less memory compute, less GPUs, less other computational thing that you need at the uh, infra side, right? That's what it does. So if you look at the numbers in the research paper, they say that low REFT, which is again low rank, it's 15x to 65x more parameter efficient. That's how they say it. Okay, so these are the REFT versus. So let me just write a few number over here. You can see it on my screen. Now, if you talk about REFT, the first thing is that it's basically looks at learn. So let me just write it over here. Learn task specific interventions. So let me just do that. learn task specific intervention on hidden representation. That's what it does, by the way. Now if we just, that's the first thing. The second thing is which is about low reft, and of course we're going to talk about it, guys. We have to talk about this, and if I have to write it in a better way, so let me just write that. Okay, otherwise some of you might say that it's not making sense, and I'll just cancel this. Okay, now some of you might say that I'm not writing in the right way. This is how you basically write this, called low reft, which is, I'm not going to write the complete full form, but low rank, and I'm just writing reft after that. Low rank linear subspace reft, which is 15x to 65x more parameter efficient. So let me just write it over here. Then Dora, guys. Dora, to be honest, is one of the most hyped and overrated techniques. I don't recommend to use Dora for fine tuning. Don't use that. Some of I have used that. It really hallucinates. Doesn't make sense. If just improves the performance by few % and people have hyped it a lot. Okay, it doesn't make a lot of sense to use Dora for fine tuning processes. Now we're going to talk about low rate performance after this. Just from the research paper, we'll see what are the different things that they have shown. If you go to the research paper, they have shown some numbers that you can probably talk about it if you want to talk more. And if you just look at the some of the numbers that they have achieved, if you just want to write about Llama 7B, we are first looking at these numbers and benchmarks, then we go into the coding part of it, guys. If you want to skip this part, feel free to skip. Now if you look at llama 7b numbers in the research paper, low reft achieves a higher accuracy. So using low reft, if I just have to define that, it kind of achieves around 80.2% with only, and this is the interesting part, with only 0.031% of parameters compared to Dora. Okay, now just imagine if you compare head to head about these numbers, Dora is around 78.1%, and the now here is the thing. The parameters count, if you look at, is around 0.838%. That's what according to the research paper on Llama 7B. Same is for 13B, which is around. So if you talk about 13B, Llama 13B, this goes even a bit higher, 83.3% with 0.02% of parameters. If you compare the same with Dora, which is even higher. Okay, so this is what they have been saying on. This is on the reasoning part. This is on common sense. You can also look at more details. They have arithmetic reasoning. They have instructions based following, and so on and so forth. So in conclusion, guys, REFT method, particularly low REFT, that is what we are looking at, that basically offer a highly efficient and effective alternative to traditional weight-based PEFT methods like QLoRa, Dora, and so on and so forth, right? Now you can also, if you want, we can go inside a bit more uh, technical over here. I have some notes, but I'm just thinking out to take a simple example. Now imagine you have a frozen language model, so I'm just going to write over here that we have a frozen language model. So I'm just writing frozen lang model, and my frozen lang model can be llama 7b, for example, if this is my model that I have. Now the model's parameters are not updated during the fine tuning process. That's what the frozen language model for in this case is, that it's not going to update it in the fine tuning process. That's the frozen based model. Now the next thing is task specific intervention. So let me just write it over here. Task specific intervention. Now our goal in this video will be to fine tune model for a very task specific. Like I have created a medical related data sets. I will show you using chat gpt, but in case you can also have sensor based data or a physical interaction question answering, that's called pika, for example. If you want to do that, that's a very famous data sets nowadays for task specific evaluation. And then instead of updating the model's weights, low rep modifies the hidden representations at certain layers and positions. That's what it does. So it does not update the model weights like the other weight based PEFT. Rather, it modifies the, so all of the neural networks, when you talk about, right, they have hidden representation. So it basically modifies the hidden representations at certain layers. You go from one layer to the other layer, and some positions as well. That's what it does. So you can have an intervention mechanism. You can identify the hidden representation. They have given that in their research paper. So I'm just going to write it over here, the word. So you focus on that, called hidden representation. That's what it is. And if you read that, they for example, if you want to call this h, for example, at each layer of the input tokens, now you're putting some input tokens in each layer, and you basically define that as h for the hidden representations. Now you learn the low rank projection matrix, which is r, of course. And the next thing is, if you want to come to the formula, okay, so low rank projection matrix. So let me just write it over here, and I'm going to call this r, which is nothing but, this is what the it learned. Okay, so a low rank matrix is learned, which projects the hidden representation. So this r that you see, it is nothing but this is something that finds this h in a lower dimensional subspace. So that's what LO, when you talk about low rep, so we talk about low rank linear subspace and blah blah blah. That's what the lower dimensional subspace is. Now then we intervene on representation. That's where the data comes in. Now you can have, of course, you can have a formula with basically, it's in documentation. They have given a formula which is a bit lengthy. I'm not writing it over here, but I don't know if I can uh, have an input sentence. Let me just bring it over here and to see if that makes sense to me. I've created some notes, but questions, choices. Hold the nail and hit it with the hammer. Choice is correct. I think we'll skip that part now. So just keep this in mind. So you have low rank projection matrix, which goes and identifies the hidden representations, and then you bring your data, of course, here. So just for example, uh, everything remains the same, like the forward pass, the loss, the the loss ratio, the errors that you have, everything remains the same. It only apply the low reft intervention, which basically uses the learned R, which is the projection matrix, the W, which is nothing but the weights, a learned linear projection matrix, and B is a bias vector. So everything remains same, and then you just create something like a formula of it's called phi low reft, and then H multiplies with H. So I'm not going into it, but there are a lot of benefits when you talk about low reft. Significantly fewer parameters compared to traditional fine-tuning PEFT method. It might use 0.03% of your model parameters in most cases. Despite the reduced number of parameters, low rate achieves higher accuracy. In common sense reasoning task, it has outperforms most of the other weight-based PEFT. And this is what we're going to look into this. Now, if you look at here on uh, this code, I'm running it on, let me just do that over here, guys. So what I'm going to do is, I'm just going to, probably this is fine. So let me just bring it over here, and I'm just going to run this. Now you have to just clone the pyreft repository from Stanford NLP on GitHub. Now if you look at this training example, this is what I have created from ChatGPT. I use ChatGPT to create this. I have an emoji. So for example, I'm building a chatbot, and that bot is nothing but an emoji bot uh, for the patients. For example, if there's a patient, who wants to, or not patient, it can be any generic user as well. So for example, look at the first question. It says, what are common symptoms of a cold? How do you treat a headache? And I have emojis to respond to that, and that's what pyreft also has on their repository. But I created my own data samples, using LLMs, and you can see what are the side effect of aspirin. So it tells you that you might get dizziness, you might get a bit dizziness, you'll feel sleepy, and that's right. How do you measure blood pressure? So that the stethoscope, there is a graph, there's a machine basically goes up. So responding through an emoji, just to bring a bit more experience layer on how do you respond to the Gen Zs. Now if you look at the Gen Zs guys, who are, I don't know what I'm not a Gen Z, by the way, but if you look at the Gen Zs, they like to interact with systems nowadays very differently. They do not want to work with a legacy based system. That's how the natural user interfaces are also evolving. We are looking at more voice enabled portals like GPT-4 Omni. I have shown promising capabilities on the voice standpoint, the speech part of it, and that's how you can also bring a emoji layer into it. And that's what we are doing here. If you look at how should I do if I have a what should I do if I have a fever? So if you have a fever, you take medications and you sleep. So I just created this question answer pairs. The answer should be an emoji that explains the feelings, the emotions, and then you have the question. So let's just run this up. And once you run it, These are pretty standard things. So let me show you what I'm doing. So I have a device CUDA, and then I have a prompt no input template, and very basic thing, guys, system prompt kind of a stuff. And then I'm using tiny llama over here, a very small. Of course, it's a large language model. In the industry, we say that if anything is above 1 billion parameter, you can call it as a large language model. You can see it says Tiny Llama 1.1b chat model. I'm using transformer auto model for causal LM. Causal LM because uh, it's not mask language modeling. It's a text generation task. So we are using causal LM. Okay, and then we have model name that we are passing it over here, and then we have bfloat 16 if you are on the newest GPU like A100 and stuff, or even the RTX thing that you have. And then you have device map CUDA. Then I'm using the same tokenizer thingy, model max length and padding side right, and then I'm having a unique token which is the pad token. I'm just calling that. And this is what getting the ReFT model. If you look at this part here, what it does, it says layer 8 component block output low rank dimensions. For that's what I'm talking about, the low rank dimensions. If you talk about that in the linear subspace that we have, and that's why this part is important for you to understand. Now we have low rank dimension 4 blah blah blah, and it's passing this getting the ReFT model. Like you get PEFT model, like get underscore PEFT underscore model. Here we are doing get ReFT model, passing the model and the ReFT config. Just like you pass the LoRa config, we are passing the ReFT config. And then we are just saying, okay, this is fine. ReFT model.set device CUDA. I think we can just pass device over here as well, but this is fine. And you can have a look at the trainable parameter. In this case, which is around 0.0014. Okay, trainable intervention params this much. And then I'm just this data module. You have to do that. You have to create a data module out of it to basically structure the data before the fine tuning a bit. You can look at here. It's this tokenizer model prompt to input, passing that system prompt over here, and this is fine. And then have a training argument. Of course, you can uh, again we are using transformers training arguments. Of course, you can bring all those find hyperparameters over here, whatever is available in training arguments, but I'm keeping it pretty standard. Number of training epochs, output directory, the temp folder. You can see that it has already been created, so I already have done that. Over here you can see all the files. You can push it on HuggingFace as well, guys. You can do that. And then I'm just doing trainer.train, and if you run this, you can see this is how it works. So let me just do that quickly. Why not? So I just run it here, and it takes really less amount because you don't have an huge trainable parameters. But again, right, if you have a bigger data sets, this will go higher. It will take more time, but I have only 50 samples, so for me it will not even take 2-3 minutes. You can see how fast it is for my cases because I only have 50 data samples. And after that I'm saying, and let me show you that what I'm gonna show you here. So if you look at this, where is that? You can look at the question is what is a balanced diet? Now this is in the training sample. So I'm not asking the same question because it might sometimes the model might overfit and it might look at the same questions and respond to it. So I just made a bit of changes in the question, and I'm saying tell me about the balanced diet. I'm not saying what is a balanced diet. So I just changed the verbatim a bit. So if you look at here, tell me about the balanced diet. And this is done. Ah, you know, probably good, looks like a good training loss, but this might be hoax. We have to look at some other metrics over here like validations loss and so on and so forth. And if I look at this, I'm just having an instruction, and let me just run this now. Once I run it, you can see how fast it is. We already am, of course, I'm on L4, so it will be a bit fast. Tell me about the balanced diet. Now this is what I did assistant. It You can see a balanced diet is eating fruits, eating some meat. Sorry if you are a vegetarian or a vegan, you might not like this answer, but let me ask some other questions just to cover up that. So I'll just cover that. Uh, who Let me ask this question. What question should I ask over here? Okay, let me ask this. What should I do if I have headache? Let me ask this question now. If you look at this question, it tells me that take medications for the headache. And This is great. Now imagine it really domain specific downstream, guys. Really downstream, very specific to the task that I have. And if you have other kind of tasks that you have, so make sure your data quality is really good. And and when you have that low reft, you can, of course, based on low reft, it uses significantly fewer parameters than the other weight-based PEFT. It will take less memory compute, GPUs that you need to fine-tune it. Despite the reduced number of parameters, you'll get a higher accuracy as well for the common reasoning task or very specific task. Now, if you look at here, let me just ask one more question, and before we close this experimentations, now tell me if let me ask this question: what can go wrong if I am dehydrated? Yeah, it tells you that you should take water if you are, or what can go wrong if I'm dehydrated. I might not feel well. I can might feel like crying. I might feel a bit warm, heat and stuff. I liked it, so this is great. Now, what else I can ask here? How can I prevent back pain? So let me ask this in a different way. What to do if I have back pain? I don't know what it has given. It has given us something. Okay, let me. I don't know. This is really small to make it a bit bigger to see what. I'm not an emoji guy. They don't understand what. So back pain. It has given something, with the back pain. I'm not sure what it is. Probably looks like a wrong answer to me, but makes sense. I don't know if it's wrong answer. Let me know if that's the right one. Okay, I'm not a guy who understand emojis. Probably you understand much better than me, but this is what it is, guys. I wanted to cover something on rift, low rift, and we'll see more techniques like this. We started with LoRa, QLoRa, Dora, multiple others, different alignments techniques, blah blah blah. And I think these are the techniques that will help small language models, or I think these are techniques that will make small language models more powerful. If you look at tiny llama, if we have domain specific tasks, if you have different tasks, you can bring it over here. You can fine tune a small language model, you can run it on CPU as well, because these are something that will not take a lot of time for you, and that's what it is. Now this is what it is, guys. I will share the this repository, this notebook in a repository on GitHub. I'll share the link in uh, description. If you like the content, please hit the like icon, and if you haven't subscribed the channel yet, please do subscribe the channel, guys. That helps me to create more such videos in near future. If you have any questions about this topic, any other topics, feel free to ask me in the comment. You can also reach out to me through my social media channels. Find the information on channel banner and channel about us. That's all for this video, guys. Thank you so much for watching. See you in the next one.